Okay, everybody check their silos in the back. Go take a look. So everything's running. That matters. As you see, the snow is done. Anybody else have any assignments to turn in? Okay. So what we're going to talk about today is dry cow rations. Would help if you could see that. Okay, so we're going to use a slightly different form than we used last week. So we have a box of forms up here. Take as many as you need at the end of the class, but we'll start you out with two for the moment. One that you can do notes on in a couple minutes. The other you can leave blank and keep as a reference. So form. So pretty similar to the one we used last week. The major change is that we're going from TDN on a percentage basis to net energy lactation, NEL, on megacalories per pound. So you'll see pretty much wherever we had TDN before, we now have net energy lactation. The biggest change from what we did last week will be on our feeds down here when we figure out how many pounds or how many last week we did pounds of TDN per pound of feed. This week we're going to do megacalories per pound. So we're not going to have to move decimal places. You'll see that probably is a little easier if we can remember which way to go. So just doing megacalories per pound in each of those planks there. And then the multiplication going across. So the cheat sheet associated with the NEL form. This is both the plank form and the cheat sheet are up on Brightspace under week 10. So front, back. So cheat sheet. We don't have to divide by 100 anymore. We just move things down to our energy space and multiply across. We've got pounds and then megacalories per pound. So when we do our math going across, we have pounds times megacalories per pound. That's going to equal megacalories. We do our cross cancellation. So we don't have to divide by 100 anymore when we're dealing with the energy values like we did last week. So pretty much the same movements that we had last week. So putting through. So any questions on the form? Next up, instead of me giving you the requirements in step 1, you're going to use table 2 from the NRC 1989. It's a nice table to break things down to make sense of where everything belongs. So on one sheet of paper, we have all the information that we can use for our substitution ration balancing. So daily nutrient requirements for lactating and pregnant cows, i.e. table 2 from the NRC. So we're looking at maintenance for mature lactating cows. So animals that are not growing, not pregnant, not milking, not gaining or losing condition will be in this category. We're not going to have many of those lactating or maintenance rations in and of themselves. We'll be combining them with other things. So you got maintenance plus the last 2 months of gestation. What do we call those? Dry cows. So usually in the last 2 months of gestation, the animal's dried off. So what do you know? If we look at our requirements, this is going to be maintenance plus pregnancy. So they're adding those 2 conditions together and giving you a total. So they're doing the math for you. Down here at the bottom, we have the energy, protein, calcium, and phosphorus needed to produce each pound of milk. So if we want to do the lactation requirements, we have to do some multiplication. So we have the body weight for a range of animals, 900 to 16 or 1500 pounds for the animal. The column we'll be using is the net energy column, the feed net energy in megacalories. The next one, energy pounds of TDN, we're not going to use that column. If you're like me, you sometimes get confused as to which energy column you're in. I put red lines through my sheet to make sure I don't use that second one. Then we have a column for the total crude protein pounds required for an animal that big or in that state. And then we have calcium and phosphorus. We might use those after break. I haven't decided yet. But we're going to focus on the energy and crude protein needs for our cows. Those are the things we need to get right on the farm. We usually have the minerals taken care of by some sort of pack we get from the company we're working with. So how do we use this table? We'll take her body weight, and then whatever her body weight is, we'll work our way across. What happens if she's not an even 100 pounds? We could take something in between, or an average of above and below numbers or something like that. We don't have to be that exact, and they're not huge changes from one to the other. So if we've got a 1,200 pound dry cow, last 2 months of gestation, she's going to need how many megacalories? 11.72. How many pounds of crude protein she's going to need? 2.47, 0.1079 pounds of calcium every day, and 0.048 pounds of phosphorus every day. So we make sure that the pile of feed we put in front of her each day has those components in it. So if we're looking at, let's say, a 4.0 test, we have to figure out which milk level of fat we're producing. So they, on this particular table, they just broke it out by different fat concentrations. If you're really going to be scientific about it, you have to account for both the fat and the protein. We'll get to that. But for right now, we're just gonna play with the fat level. So let's go with 4.0. So for every pound of milk, we're gonna need 0.33 megacalories to support that pound of milk. So if she produces 100 pounds, how many megacalories are we going to need? 33 megacalories to support 100 pounds of 4.0 milk. And we do the same thing. We multiply by the pounds of milk, working our way across to get the total nutrients associated with that production of that milk. So if you're a lactating cow, you're going to get her maintenance requirement and you're going to add that to her milk requirement. We just said a cow producing 100 pounds of milk 4.0 is going to need 33 calories. How does that compare if she's 1,500 pounds? How does that compare to her maintenance requirement? What's her 1,500 pounds? What's her maintenance requirement for energy? 10.66 versus 33 for the milk she's putting out. What's the ratio there? More or less. 1 to 3. When you say she's 3 times maintenance, that would be an example of a cow that's 3 times maintenance. She's putting out 3 times the calories in her milk that she's putting out or just needs for her body. So when we're looking at our defining our animal, we have to decide what we're going to need to account for as we define that animal. Maintenance, we certainly have to do that. And then which of the following conditions are also in play? So if we do maintenance in pregnancy, a dry cow, we're probably not going to have to worry about lactation, maybe growth in the first calf heifer. Lactating cows, right after they calve, we deal with maintenance, lactation, possibly growth, depending on what age they are and where they're at. So if I look on back on this table too, where are my maintenance requirements? This whole section right here. Where are my pregnancy requirements? Second section is maintenance plus pregnancy. So if I wanted pregnancy, I have to subtract to find the difference. They've done the math already. So if we look at that 1,500 pound animal, 10.66 for maintenance, maintenance plus pregnancy, she needs 13.86. So what does that work out to? 3.2 calories going toward pregnancy. So pregnancy we'd find by difference. Where do we find lactation? This section down here. So we add things up. There's growth. It's there.
Is it the difference between the body weights?
Nope. The thought, but no.
Is it your milk minus your maintenance and your station?
Nope. We've got maintenance. We've got maintenance plus pregnancy. So by difference, we can figure out pregnancy. Lactation's a standalone area. Where's growth? There's the only place you haven't looked yet. Footnote at the bottom. Probably not the most accurate way to do it, but They're saying to take maintenance, multiply it by 10% to get second lactation growth, multiply it by 20% to get first lactation growth. So first lactation animals, we're gonna have maintenance, lactation, and growth. Mature cows, we're just gonna have maintenance and lactation. So we'll get to that next week or the week after, depending on how our cow is feeling. Any questions on table 2? So that's step 1 on our form. We'll use that table 2 for the next couple weeks. For step 2, we're going to use some average values published in the NRC, National Research Council. So this is chapter 15 from the 2001 NRC. I think this is the easiest one to read. So you might want to put your name on it. I find it somewhere, I know who to give it back to. We do have a couple of extra ones we'll keep up here in case you lose it. So I put my name on the front, so that way all the notes and stuff I put in there, somebody hopefully will bring them back to me so I can get what I need. So you have a kind of an introduction about how all those numbers were figured out and put into the table. So you flip 1 page, 2 page to the top where it says 283. So we have a table here, nutrient composition and variability of some feedstuffs commonly fed to dairy cows, all values on our dry matter basis. So if we take a look here, you got first page, second, third, I think there's 9, 4, 5, up to 289, so 7 pages. There are 121 feeds in this table. We're going to use them to balance rations. So going back to 283, we've got over in this left-hand column, we have an entry number. This will be match the reference number on our feeds. Over here, I will tell you, I think on homework problem number 2, please use the feed composition table feeds 54, 31, and 107. So I'm directing you to which row I want you to use. So that'll be the first thing on the form. So we'll use those quite often. And then the alternating gray and white tends to put feed types together. So we just have one feed up in that first row. We have alfalfa. You have its Latin name, and then you have alfalfa meal, the subtype, 70% crude protein, and then the information related to that. If you skip down to here to bakery byproduct, there are 4 subcategories under that heading. So we have byproduct meal, we have bread, cereal, and cookie waste, effectively. Leftover from bread baking or bread that's returned or molded or whatever. You've got cookie or cereal byproduct and cookie byproduct all under that bakery byproduct heading. So depending on where you are, if you're close enough to one of those plants, you may have an opportunity to get one of those feeds. So we got the name or description column. We have an international feed number. So different languages, different countries, we can compare feeds. They all reference back to the same feed number. And then we have a series of energy values. So TDN we've talked about. We got digestible energy, maintenance energy, 1, 2, 3, 4 net energies before we go into other compositional numbers. So working our way across the top, TDN. We're doing that 1x means 1 times maintenance. And then with TDN, you've got forage or concentrate equations, 2 separate ways of calculating that based on what the feed is. So we're not going to worry too much about those columns. We're going to skip over PAF. I don't know what that means. I forget at the moment. We're going to skip digestible energy, maintenance energy, and go to NEL3X. That's the column we're going to use for energy. I've gone through my tables because my eyes don't track as well as they might. And basically on each page, mark that column. You can take a highlighter and run it down. Given all these numbers, sometimes I move back and forth. That's my way of making sure I don't move back and forth between columns. So we're going to use NEL3X. 3X means number of times maintenance intake. So she's 3X maintenance. And it's measured in megacalories per kilogram. Would I be correct in assuming that you, as a class, would prefer to use pounds and not kilograms? So we need to know how to convert and make some adjustments. So our conversions, does everybody know how to convert back and forth between pounds and kilograms? Well, that's what Google's for.
Not like 2.2 grams or something, is it? Or no, 2.2 pounds is a gram. And then,
No,
no,
you're on the right track. You've got the right number. You just don't have the right units. So as we go back and forth, our numbers here, kilograms times 2.204 pounds per kilogram is going to get us kilogram or pounds. So we cross out, cross cancel, kilograms, we're left with pounds. That's how we make a conversion. If we're going from kilograms to, or pounds to kilograms, pounds times 0.454 kilograms per pound is going to get us over to kilograms. So the pounds cancel out, we're left with kilograms. So if we want to change, and this is what you're going to have to do with your megacalories per kilogram, you're going to multiply by 0.454 to get megacalories per pound. So that has to do, if you're looking at the equation, kilograms being on the bottom, we've got then we want to have megacalories per pound at the end, cancel out the kilograms, and that's how we get from one to the other. You could divide if you wanted to, but I introduced that to the last class and I think I confused them more than anything, so we'll just not say that out loud. You've got those equations there to do that. You might note at the top of the page for your NEL3X megacalories per kilogram. I write at the top, please convert to megacalories per pound. If you pull the megacalories per kilogram and start trying to balance, you're gonna run into a world of heartache because these rations are not designed that way. Not that you can't, you can certainly balance that way if you want to, but it'll be a little confusing. So we're gonna focus on the NEL 3X. That's the one we're gonna use, both the dry cows today and for the lactating cows in the next weeks leading up to Thanksgiving. So that's the column we'll use. What else is in each of these rows? You got dry matter percent, crude protein percent, neutral detergent insoluble crude protein percent, acid detergent insoluble crude protein percent. So how much nitrogen is for crude protein? Nitrogen times 6.25 is in the NDF. How much is in the acid detergent? Ether extract, that's what? What's a synonym for that? Ether extract equals what? Fat, crude fat. Good way to think about that. Percent NDF, percent ADF, lignin, and then ash or minerals at the end. So that's the first 5-6 pages. Those are the ones we're going to focus on at least till Thanksgiving. You've got some other numbers there that just make you aware of them, what they are. Is anybody here taking stats? So we got 2 over here. So N equals what in stats? Sample size, the number in the sample. So you got N here. The second row tells you the number of feed samples that went into the average appearing above. So this is the average value for dry matter, crude protein, NDF, ADF. We have like 220 feed samples that were averaged to get that number. If you look at neutral detergent insoluble crude protein, there's only 3 numbers there measured on a alfalfa meal. So this is probably going to be, we assume, more representative than something that's just made from 3 numbers. So looking at those numbers, you can tell how much confidence you should have in that number by the number of things that went into that. Standard deviation, SD, talks about the variability of that data set around the average. The bigger that number is, the wider the data set is. Who here has done standard deviations? So you guys in stats. So dry matter is not going to vary all that much. It's a dry feed. They all come in around 90, give or take a few points. So plus or minus 1.5 versus our ADF and NDF. Those are going to vary widely depending on the source material that we put into that alfalfa meal. So 42 plus or minus 7 is a much bigger range than 90 plus or minus 1.5. Everybody with me so far? All right, so take a look at that first page. We have alfalfa on there. We have almonds as wholes. We have apple pumice. So you can say these names any way you want to. Barley we'll be using a few times. You could pull sugar beets, beets, comma, sugar, pulp, comma, dried, beet pulp. So the official name there. Got Bermuda grass, blood, bluegrass, brewer's grain, smooth brome grass, reed canary grass. Canola starts on this page and continues on to the next page. Got your chocolate byproduct, your dried citrus pulp, 2 clovers, And then a whole lot of corns. We're gonna be using them quite extensively since that's what we do in the Northeast. So you've got corn, yellow corn of a bunch of different types or subtypes. You got just the cobs. You've got Stiller's grains with solubles in them, which is what we saw on our feed ID. Corn gluten feed, corn gluten meal, corn cracked and dry, corn ground and dry, corn steam, grain steam flaked, grain rolled high moisture, grain ground high moisture, grain and cob dry, grain and cob high moisture. You got hominy, and then you got 3 examples of silage at the bottom. Immature, normal, and very mature. So we'll be using those as the semester goes on. Cottonseed at the bottom. Over on to 285. We've got cottonseed hulls, cottonseed meal. You got a variety of fat sources and oil sources, feathers, fescue, fish byproducts. Then we get into grasses cool season, which is pretty much any grass that grows around here. Timothy, orchard grass, etc., etc. So it breaks it up into pasture, hay, various levels of maturity, and then an overall sample. Same thing with silage. All silage averaged, sample silage is averaged together. And then the subsets of immature, mid-maturity, and very mature. Flipping over to 286, you've got grass legume mixtures with the same breakdown as we had for the grasses. You've got a mostly grass section, half and half grass and legume section, and a predominantly legume section. So picking the one that seems to fit the best. Flip over to the next page, 87. We got legumes. The breakout is the same as we saw with the grasses and the grass and legume mixtures. Linseed, beet, molasses, oats, orchard grass, peanut. Flipping over to potato, rice, rye, ryegrass, safflower, sorghum, soybeans. We're going to be using a lot from that section. Different types of soybeans, either hulls. So we got 4 different meal, depending on how they're processed. 2 seeds, whole and roasted. And then silage, if you cut it early enough, you might be able to make silage out of it. Sunflower, timothy, bird's foot trefoil, tomato pumice. I don't think I've ever seen that in front of a cow, but I'm sure it works. You're next to a tomato processing area. Triticale, wheat, and a popular one in this area, whey. So those are the tables and sections we're going to use most. I provided the rest just to give you a feel for the variety. So next up is table 15, 2A, nitrogen fractions. So all the different nitrogen fractions, got some of those we discussed in class. And then we get over on the side here, we got your individual essential amino acids, what the projected concentration of each of those is in these 121 feeds. So you're flipping through 91, 92, 93, 94, 5, 96. They have all the same feeds as you had on the previous section, just different stuff in them. Get up to 300, I think, or is it 299? 290, 300. We've got some other fractionization based on our percentage of the dry matter. These are feeds that don't match what we did previously. So these are weird stuff that we didn't have in the common list. So these are a little bit more there. So different alfalfa cubes. We didn't have that in the previous page. Bunch of different barley things that were not there, but somebody has amino acid concentrations. Putting them in allows people to use those for references. Page 304, we start mineral concentrations. So table 15.3, mineral composition of most common, some feed systems commonly fed to dry cows, all on a dry matter basis. This is going back to our first list of same feeds all the way through. There'll be the same amount on each page. You have the total ash, which is what we had in table 15.1. You'll have your macro minerals, the next 7 columns: calcium, phosphorus, magnesium, potassium, sodium, chloride, and sulfur. And then we'll have a bunch of micro minerals. The last 8 columns there are all micro minerals that are present in feeds. So you have mineral concentrations. We might use those after Thanksgiving to balance some rations for minerals. We get up to 311. The rest of that chapter talks about different sources of various minerals that we had and their digestibility. We'll explain that when we get to minerals. So you have way more than you need there, but it should be helpful as we do things for the semester. So let's take a stab at a sample dry cow ration. So we'll be using this form, front and back, and your assignment at the end of it all, remind me to give the handout. You've got 3 rations that you'll be doing as a homework assignment over the next week. So what I'm going to do is bring up a blank form. Okay, so we're gonna start out with, this is gonna be our example ration. So you might put your name in there. Whatever you want to do, you're keeping this at the end, your MID. We got LabWeek10. Problem number, this is going to be our example. So we're going to do a dry cow, animal description. That animal is going to weigh 1,300 pounds. And his dry matter intake is going to be 2% of body weight. So in order to do a substitution ration, we're going to need 3 feeds and 3 requirements. So the 3 requirements we're going to do are dry matter intake, net energy lactation, and crude protein pounds that we need. So where are we going to find dry matter intake? Or how are we going to find dry matter intake? So everybody follow that, right? 2% of body weight. We divide that by 100, 0.02 times her body weight. So percent of divided by 100. What's that going to give us for her dry matter intake expected? So 1,300 times 0.02 should give us 26 pounds of intake that we have to play with. Where are we going to find our megacalories required per day? We need our table 2. Where are we going to look? Middle section. Make sure we get 1,300 pounds. So how many calories are we going to need from her for her to sustain her each day? So does everybody see where that number comes from on that table 2? How many pounds of crude protein? So as a general rule, seems to work out okay. I will carry dry matter intake. Dry matter intake to 1 decimal place seems to work okay. For energy, whatever I'm using. EDN, NEL, 2 decimal places. Seems to work. Protein. Three decimal places. You have to? No, you can make them all 2 if you wanted to. But that seems to work for me, and that's the way I'll be presenting the examples. So we have our requirements for our animal. We pulled it from table 2. Next up, step 2. Find the feed composition of feeds to be used. So feed number. I'm going to need my number 1 feed, 2 feed, and my 3 feed. Does anybody remember from last week what those feeds are? Or description of those feeds? How do we describe those feeds?
Number 1, right?
Can be, but it's the category that we're dealing with, or description.
Forage.
It's forage usually. But the key thing we're looking for is the amount of energy, the amount of protein. This week, I will make sure that things are kind of laid out in order, that as you pull them off the page, they're in the right order, 1, 2, and 3. I won't always do that. And if you don't double check on that, you're gonna get some really funky numbers. So our first, what do we know about our first feed from a energy and protein standpoint? Low, 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 and we're looking at usually a forage. What do we describe our feed 2 as? High in energy, low in protein, and that makes it a what? concentrate, but specifically an energy feed. We said our grains fall nicely into this category. Our last feed, our feed 3, was high and high. What did we call that generically? Protein feed. Protein feeds are usually high in energy as well. Everybody with me? Okay, so I'm gonna give you a grass silage, a cracked corn, and a soybean meal. Which one's gonna be which? Grass silage is probably gonna be what? Number 1. You've got corn versus soybeans. Which one's gonna be which? Corn's gonna be our 2. Soybeans gonna be our 3. So we're going to have a grass silage. And soybean meal 44. So for the reference number or the entry number, I'm going to give you the composition of the egg. For our reference number for cracked corn, we're going to use 26. And for the soybean meal, that's going to be 106. So for the grass silage, I'm giving you the numbers. We're going to make it 36.0 for dry matter percent. Energy is going to be 0.4 megacalories per pound. And we're going to say this grass is 8% crude protein. So that I'm going to give to you. Now we need to look up our cracked corn. How do we do that? We go to our table 15.1. We find feed number 26, which is where? On page 284, the second page. We work our way down. We have grain under corn yellow. We have grain, cracked, and dry. So that's cracked corn. So what's going to be our dry matter percent for that feed? 88.1. So it's helpful for me. I think it's because my eyes are old, but I tend to use some sort of straight edge. So folded piece of paper, Post-it notes. If you take the 3x3 and you fold them diagonally, those work nice too. So 26, what is our energy value? Which column are we using?
3.
The 3x, so NL, net NEL, 3x. What is our energy value? 1.91. Does everybody agree with that? Shouldn't. That's in megacalories per kilogram. Remember,
Oh, yeah.
we got to make that conversion. So you might want to write at the top of the page, make that conversion. You also, as you go along, you might write down the conversions in there. I do. So I don't have to, it reminds me to get the right one. So to write the handwritten number there. So if we make the conversion, what do we come up with? Which formula we're using?
0.454.
So it's gonna be something about half whatever's in the table. So keep that in the back of your mind. So we multiply the megacalories per kilogram times 0.454. So that's the bottom equation on your list there. So I got 0.87 rounded it to 2 decimal places. What is our crude protein for this feed?
9.4.
9.4. So flip over. Feed 106. We've got soybeans, meal, solvent 44, crude protein. So what information we have for that one? What's our dry matter? 89.1. What's our energy value? $14. You did.
Yeah. I went the wrong way.
I got 0.97. So what is that? It's 213 times 0.454. I think you forgot a decimal place somewhere.
4.54.
Crude protein, where are we with that? $49.9, half crude protein. Everybody following step number 2. Okay, so we have our animal defined, our feeds defined. We start to play with the interaction. So down here, her feed 1 is what? Grass silage. You have to write all this stuff in. No, but it helps make sure I'm on the right page. So you'll have to make sure that feed 1's the forage. So what's going to be our dry matter intake pounds? We're going to feed her all she can eat. That's 26 pounds versus the requirement. That should always be 0. So where do we get this? I'll bring that down. So what is that? Nope. .40. Just bring that down there. So different than last week, we don't have to divide by 100. We just multiply this by this to get this. So this is megacalories per pound. You got 0.4 in every one of those. Multiply it out. What does that give you? Everybody happy with 10.4? We compare that to requirements. 12.45. We subtract one from the other. and we find that we are short 2 megacalories, just a little over 2.05. Everybody with me? So do we keep going? We're off by more than 5%. That's what, 20%? 20, 15, 20% off. So we got to keep going. So that means we got to set up for our next trial ration using step 4. So energy in 1 pound of feed 2. What is that? 0.87. So we just take the megacalorie concentrations. So feed 1, what do we got there? 0.4. So every time I pull out 1 pound of dry matter from grass silage and put back 1 pound of cracked corn, I'm going to gain in megacalories. The pile will get that much more. 1.47 megacalories every time I make that swap. If I take pile of grass, pound of grass out, dry matter, I'm going to pull out 0.4 pounds. I shove in that cracked corn. I'm going to put back 8.7. So every time I make that swap, 0.47 megacalories are added to the pile. So I go down to the next line. How many megacalories do I still need? 2.05. I just take that from up here, drop the minus sign, bring that down there. Gain from feed 2. What do I put there? Bring down this number right over there. So bring that down from the previous 9, 0.47. So that gives us what? I got 4.4. Am I wrong? Is round to 4.4?
Yeah.
So again, just doing 1 there. If you want to carry out the decimal places, you're more than welcome. That's going to make your numbers sharper as you go through. So I got to figure out what my next ration looks like. I start with my dry matter intake requirement, 26.0 pounds. My amount of feed 2 that I'm substituting in, pulling out 4.4 pounds corn silage dry matter, putting 4.4 pounds of cracked corn back into the pile. That's going to leave us with what? 21.6 is my new weight for feed 1. So feed 1, feed 2. Take those numbers. We flip over to ration 2. So feed 1. Grass silage. So 21.6, 4.4. So how do I get this section right here? Oh, where do I get this from? Nope. Where do I get this from?
Oh,
I did the other one first, but still you don't add them together. Where do you get this from? Step 2, same over here, step 2, you just copy the numbers over. How do you get this, these two here? Multiply this times this gives you that. Do we move the decimal place? No. We get this over here, how do we do that? This times this divided by 100 gives you this. Do I see my jump in the cheat sheet? You jump over, and then we total 1, 2 gives us this, 1, 2 gives us this, 1, 2 gives us this. Where do we get this row? Step 1. That minus this gives us this number down here. So take a crack at those numbers. And we'll compare notes. How'd I do? We're just. Probably should be disagreeing, right?
For the grass silage for the crude protein pounds, I got 1.728.
Yeah, me too.
Everybody else should have gotten that, right? So working the grass silage row. What about the other numbers in that row? Everybody happy with those? What about the cracked corn? You agree or disagree with those numbers? You got 2.8 above, you probably should have had. 414. So what does that do? That changes your total. What's the new total? 2.1 what? About that? 2.142. How about those numbers? Everybody happy with those? So difference between what I put up there and what you guys got is rounding error. But we'll stick with your numbers. So are we balanced? How do we answer that question? What do we have to ask? Are we within 5% on all the requirements? 5% should always be 0. 5%? So 5%, we're well below 5%. Probably below 1% difference. What about here? We're off by like 20%. So we have to keep going. Proceed to our third ration. So how many pounds of protein are in 1 pound of feed 3? Everybody remember how to do that? How do we figure that out? Good, you pull it from step 2 if you're quick with numbers. If the formula to figure that out is one pound times that's the formula for that blank. If you want to put that on your cheat sheet. Oh, we do that for both feeds. Generically speaking, 1 pound times crude protein percent over 100 equals so pounds in 1 pound. So what's that number? .499, almost a half a pound of protein per pound of feed 3. How much do we have in our feed 2? No. Can't be 9.4 pounds in a pound. 0.094 pounds, almost a tenth of a pound. In 1 pound of our feed 2. Remember, the line above gives you instructions. So what is our gain for substituting one feed for another? On a pound for pound basis. We just subtract. So minus, that gives us every time we make the substitution, we pull out corn, we put back soybean meal. Every time we do that, the pile gains 0.405 pounds crude protein. So how much crude protein do we need? Oh, 0.488 pounds still needed. Our gain, we steal from the line above, bring this down to that. So gain equals gain. So 0.405. And what does that give us? So keeping it to 1 decimal place, 1.2 pounds of feed 3 is needed to balance the ration out. We need to substitute, pull out 1.2 pounds of feed 2, or cracked corn, put back 1.2 pounds of soybean meal, our feed 3. So our old amount of feed 2, 4.4. 1.2 feed 3, that gives us 3.2 for our new amount of feed 2. So we proceed to ration 3. We've got our 3 feeds once again. So how do we get the first row? Remember the trick from last week. steal it from the first row on the previous ration. It's exactly the same as this line here is exactly the same as the one up on previous one. And then we do the same pattern as before. These two from table 2 or step 2. These come from this times this gives you this. This times this gives you this. To get these, this times this gives you that. This times this gives you that. Total everything up, compare it to requirements from step 1, and find our differences. So take a crack at those. How did I do? agree, disagree? Got 3 here to agree.
Mhm.
One possible disagreement up front here. I'm open to suggestions.
Do 4 dozen pieces is too much.
You can if you want, I don't care. I do 1, 2, and 3. That seems to work out most of the time. The rations don't go off too far. Or don't seem to go off too far when I do that. If you want to carry 4 decimal place, be my guess.
My numbers on.
But we're in the same general ballpark. So am I balanced? I.e., is each of the nutrients within 5%? Certainly, we are within 1% on, we're right on for dry matter intake, we're probably within 1% for energy. I think that's 1%, or is that? I think it's 1%, and we're well within 1% on the last. So those are rounding errors to a point. We had everything balanced for energy. What happened? Why did we go up? Anybody know?
Gained 10%.
So if I pull out corn, I put back soybean, I gain 1/10 of a pound or 1/10 of a megacal every time I do that. So last week I had everything equal. That's not the way life's gonna be. So it won't work out as cleanly all the time. So if this feed here is a little higher in energy than the previous, you're gonna cheat up a little bit. If it's a little bit lower, you'll cheat down a little bit. Yes.
So what do you do then when you have your protein feed that kicks your energy up
Uh-huh.
higher and then it winds up throwing you out of that 5%
We
range?
will try not to make that happen. But if you were, you'd keep tweaking. You'd probably take out a little bit of energy, put a little forage in, but that's when we get to spreadsheet balancing. This is too crazy to go back and redo everything by hand. So the general consensus on past classes, we do this by hand because it sticks a little better. You learn it a little bit better. It's very tedious when you start. Some of you will find this almost relaxing, like meditation. I just go through the steps, chug through. I know exactly what the flow chart is going to be. I get the metronome going, everything happens. Others of you will be frustrated. I know that. Talk to me and we can figure out something that can help you along. So what's our last step? Convert dry matter to a balanced ration to as fed, or what's a different way of saying that? What am I making? Ration mix sheet. I'm making the mix sheet for 1 cow. So we're making the mix sheet. So again, we could copy that stuff down. So pulling those numbers down. Where do we get the dry matter percents? Step 2. So we had 36. We had 88.1. 89.1. So how do we get over to our as fed? divide, so this divided by this divided by 100 will give you this. So what do we know about the aspect number? It's always going to be what?
Bigger.
Bigger, because we're adding the water back in. If it's not bigger, we did something mathematically wrong. So take a step back at the end, ask, is that bigger? If it is, you probably did it right. So that is the pile I need to put in front of my cow. 60 pounds of grass silage, 3.6 pounds of cracked corn, 1.4 pounds of soybean meal, and 65 pounds total. If she eats that every day, our dry cow will be happy for the next few weeks until she calves out. Any questions about doing these rations? Ready to try it on your own? Lauren's chomping at the bit. Give me my ration. So we have 3 rations for homework. You decide how many sheets you want to take. They're designed to be front and back. I like doing 2 separate sheets so I can have them right next to each other. It's easier for me to go back and forth. If you want to do that, take 2. I need 6, 2 for every ration. Take as many as you need, pass them around. So you need at least 1 ration for each of the 3 rations, 1 sheet for each ration. If you like 2 sheets, take 6. If you think you're going to make lots of mistakes and you write in pen, take a stack. We can get more printed. I usually have 2 or 3 extras when I'm doing it because I always screw up. So I tend to catch myself. There you go. So pass the box around.
You might as well just give me all the clear.
Bonus.
Take what's left.
So add 200 pages printed. That should get us through to Thanksgiving.
24, you can have 176.
Well, we had last class, so we could take about 150. And we did have 1 student, yeah, she's like, I'm running out of correcting fluid. She's got the little rollers to fix the mistakes, so take as many as you want.
So are we doing one sheet per problem?
Yep.
Okay.
We are asking you to do these hard copy. What I'm gonna do is make answer keys up. You come back next week with your answers. All I care about is you tried. They don't have to be perfect. When do they have to be perfect? On the lab practical. But I'll have answer keys. I'll hand them out to you guys. You can take a look and say, okay, I made a mistake there. I agree, disagree, whatever you want. And then you got immediate feedback as to how you did. So that's why I'm asking for hard copies. Does that make sense? Okay, so taking a look at this assignment. We got 3 different dry cows that you're gonna balance for. So there's also, this is up in Word file, a Word file up on Brightspace if you want to do things in the Word file like I did here. So however you want to do it, but I need a hard copy for when we get into class next week. So looking at the problems, each will describe the animal to start with. So 1,300 pound dry cow, first 2 weeks of pregnancy. So you're going to pull requirements or generate requirements for dry matter intake, NEL mega cows per day, crude protein pounds per day. You're assuming a certain dry matter intake there. I put that for each of the things there. Feed composition table, you're going to use for the first one, 26,104, and you're given mature grass silage of the following composition. So knowing what you know, which one's your feed 1? grass silage, feed 2.
Six.
26 is in the corn category, then 104 is in the soybean category. So you got those two there to help you double check yourself. I put more or less how many pounds of as fed for feed 1 will be in the balanced ration. So you've got, check your math, the amount of as fed feed 1 for problem 1 should be about 46 pounds. Give or take, depending on how you round. And then what percentage of forage dry matter is in the diet? How do we do that? Yep. So where do we get forage dry matter?
A matter of 1 over your total estimate or not.
Don't think so,
It's,
but
you would take the total dry matter that you're feeding.
and multiply by 100. Get your percentage. So the amount of feed 1 for total intake. So I think for feed, for problem 2, I think those are in order. 54 is probably your feed 1, 31 is definitely your feed 2. 107 is definitely your feed 3. So you got your given mature grass silage is your feed 1, and then probably 26 and 105 are 2 and 3 respectively. Any questions on that homework assignment? Enjoyed it that much?
No, I think it is. It's fun, it's like a puzzle. I did admire your. Well, I admire your brain. It's like, listen, I like math and I like nutrition, so this is like it. This is. There's a reason I'm trying to apply to feed companies and feed mills when I graduate. Okay. It's
Is this your last semester on campus?
Yeah.
Yeah.
I already did dairy challenge.
No,
Is that your
I meant no. Advanced nutrition, and people, nobody's taken that class for 2 years now.
Really?
Advanced nutrition, nobody seems to want to do it.
I mean, you can just send me the material. You can just email me all the material.
You get to a Teams meeting every week if you want to take it. Top of your on top of your internship.
Well, my internship I did. When I went to Little Bend over the summer, that counts. That's what I'm using as my internship.
Oh,
So,
nice.
yeah, I'm presenting that in December.
Okay.
Something like, yeah, beginning of December.
You're done.
Yeah,
Okay.
unless I decide that I want to take more classes,
Well, if you do,
which the only.
advanced nutrition
Yeah.
on your list Thursday afternoons. So, yeah. That's why I ended up teaching 405 last year. Nobody would take my class.
Mhm.
So any questions? If not, you can start. If you want here, I'll stick around to answer questions as they come up. If not, stop by the office, see me before or after class with questions. The time is yours to use as you see fit.
Said this is the dry cow version.
Like a half an hour drive.
It is for now, yeah. We'll use the same thing probably next week for lactating rations.
Oh. Oh. So. Then we came here.